One day, IP version 6 will become the default protocol used on the Internet. But until that happens, you are going to have networks that need to run IP version 4, IP version 6, or both. There are a number of technologies to help you make the transition from IP version 4 to IP version 6. In this section, I will look at the transition technologies that are available to make the change from IP version 4 to IP version 6. The first of these is ISATAP. ISATAP is used inside a private network. If you are planning to access the Internet, you can use a system like 624. 624 is a transition protocol designed to help people migrate to IP version 6. The last transition protocol I will look at is Teredo. Teredo is used when your company is using a NAT device. The protocol relies on external servers which many ISPs and even Microsoft have placed on the Internet to help with the transition. There is still a lot of work that needs to be done before everyone is switched over to IP version 6. To try to assist the migration to IP version 6, there are some transition technologies that have been developed. These are needed because IP version 6 has a different header than IP version 4. This does not affect Layer 2 of the OSI model, as Layer 2 devices will work with the new header. This means you can deploy your IP version 6 network without having to upgrade your hubs and switches. However, because the IP header has been changed, Layer 3 devices need to be upgraded to IP version 6 before they will work on an IP version 6 network. You can imagine that many companies won't want to upgrade all their routers to IP version 6 anytime soon, so transition technologies are needed. The first is what Microsoft calls Next Generation TCP/IP. Simply put, this means Windows Server 2008 allows both the IP version 4 stack and IP version 6 stack to be used on the same computer. Windows will attempt to automatically decide which to use. A lot of commands support the -4 and -6 switches. These switches force Windows to use either the IP version 4 protocol or the IP version 6 protocol. Even with next generation TCP/IP, since the whole Internet is not yet IP version 6 ready, you may have a situation in which you need to go over the IP version 4 network to reach an IP version 6 client, and this is where transition technologies come into play. ISATAP, or Intra-Site Automatic Tunnel Addressing Protocol, is enabled by default in Windows Server 2008. ISATAP is intended to be used in private networks only. It cannot be used on the Internet. In your organization, if you have an IP version 4 network and an IP version 6 network, and you want to communicate between those networks, notice there is no common protocol between the two. What you can do is install an ISATAP router between the networks. If a computer on the IP version 4 network wants to communicate with a computer on the IP version 6 network, the computer first communicates to the ISATAP router using IP version 4. In order for a host on the IP version 6 network to receive the communication, the router must communicate to the IP version 6 host in IP6. To do this, the router uses a link local address. Remember, link local addresses always start with FE80 and are used for local traffic only. In the host part of the address, you have 5EFE, followed by the IP version 4 address. Consider the following example. To communicate with 10.0.30.120, the router would use the link local address host network ID FE80, followed by the host ID of 5EFE:10.0.30.120. If a client on the IP version 6 network wants to communicate with the IP version 4 network, the process is simply reversed. With Windows Server 2008 and Windows Vista, ISATAP is enabled by default. To get it to work, you will need to configure your ISATAP router. Also, your host will need to be able to locate the ISATAP router, so you will need to add it to DNS. The good thing with ISATAP is that you do not need to perform any configuration on Windows Vista or Windows 7. These clients will detect and use ISATAP automatically. ISATAP does not support any routing, so the network you want to connect to must be connected to the ISATAP router, and thus ISATAP can only be used inside a company's network and not on the Internet. 624 is designed as a transition protocol to help the adoption of IP version 6. It was not developed to be a long-term solution. 624 allows existing IP version 4 networks to be used to tunnel IP version 6 traffic. Consider this example. There are two IP version 6 networks and you want to communicate between them. Between them you have the Internet, which at this time is mostly IP version 4, with very little IP version 6 routing. To communicate between the two networks, a 624 router is used to tunnel the IP version 6 protocol over the Internet. To do this, a public IP version 6 IP address is used. These addresses all start with 2002, followed by the IP version 4 address shown here as W, X, Y, and Z, followed by the subnet ID and interface ID. You may be thinking, why would you not establish a tunnel between the two sites? Consider this more complex example. The communication leaves the IP version 6 network and enters an IP version 4 network. The communication then travels to a 624 router and enters an IP version 6 network. From here, it gets routed through an IP version 6 network, but unfortunately, there is no IP version 6 network to the destination network. The communication again gets tunneled through an IP version 4 network to another 624 router, which has a connection to the destination network. As the Internet becomes more and more IP version 6 ready, your data will be routed more through this network and less through the IP version 4 network. Using 624 also allows your clients to connect to IP version 4 hosts. However, IP version 4 hosts will not be able to connect to IP version 6 hosts. Using 624, you could do the following. The computers on the IP version 6 network can have any valid IP version 6 address. The 624 router has one valid 624 IP address. Using this IP address, your network can communicate with any IP version 4 computer on the Internet. However, they cannot connect to you. Using the 624 protocol, you can start deploying your IP version 6 network and still keep accessing the IP version 4 network. The next transition technology is Teredo. This is available for Windows Server 2008, Windows Vista, Windows 7, and Windows XP. You can use Teredo when you have an IP version 4 NAT device that your clients connect to. If you have a situation in which your company wants to start using IP version 6 but does not want to upgrade the IP version 4 NAT device, you may need to use Teredo. Consider this network. The clients on the network connect to the IP version 4 device to access the Internet. The NAT device has one public IP version 4 address. In order to connect to an IP version 6 host, the clients contact a Teredo server. The Teredo server gives the client an IP address to the Teredo relay. The client creates a tunnel to the Teredo relay. All the communication between the client and the Teredo relay is in IP version 4, which makes the communication compatible with the NAT device. The client can then use the tunnel to send its IP version 6 traffic to its destination. In the real world, IP version 4 will be around for a long time yet. Believe it or not, IP version 6 has been around since 1996. However, development and support has been slow. Today, only a small part of the Internet is IP version 6. Adoption has been slow. However, some countries like China have deployed a lot of IP version 6 networks. Most notable was the Olympic Games in 2008, which were completely IP version 6. All network operations were conducted in IP version 6, and even the web page was available in IP version 6. The China Olympics provided the largest showcase to date of IP version 6. But in the real world, the reality is that there is a lack of IP version 6 devices. If you attempt to buy a DSL modem for home that uses IP version 6, you may have trouble finding one, and it probably will not be cheap. Companies won't want to foot the bill to upgrade their networks to IP version 6 until the prices come down or until there is a real business need. IP version 4 still meets most companies' business needs, and that is unlikely to change anytime soon. If you want to learn more about IP version 6 and want to give it a try, I would recommend visiting gogonet.gogo6.com. GoGo6 supplies access to the IP version 6 network and even provides a free client you can install on your computer. Once you install the client, you can access the IP version 6 network with your own valid IP version 6 address. If you want to experiment and learn about IPv6, this is a great way to do it, and without having to upgrade any devices on your existing network. A lot of demonstrations performed in this course using IPv6 are done with the Go6.net client. Good luck with IPv6.